Hi, my name is Lydia Quilla, and I'm here to introduce the research for long-term impact of tray-free dining interventions on food waste and student behavior. A little bit about me. I am currently a candidate for graduation from the University of New England in this August, and I currently practice as a clinical dietitian consultant. An outline for today's presentation: we're going to start with the research question and move on to the introduction, background, literature review, and then methods, interpretation of data, the risk and benefits, completing with knowledge to be gained, followed by a time for questions. The research question is, does a university dining food waste campaign reduce food waste over the long term and change student behaviors? The purpose of this proposed research is to introduce a food waste reduction strategy by implementing tray-free dining service in university dining and assessing the effects on food waste and student behaviors. Previous research has already determined that various strategies such as written messages and portion control can help reduce the impact of food waste in university dining. With the growing concern of food security and environmental impacts such as resource depletion and greenhouse gas emissions attributed to food waste, attention to the topic has intensified. The removal of trays from dining halls and cafeterias have become an ongoing trend among universities and colleges. With the move, several environmental and economic benefits are cited, such as a reduction in food waste, in energy, water, and chemicals associated with washing dishes and trays, and reduction in costs of tray replacement. Due to the environmental and economic benefits of tray removal, there has been broad acceptance of this practice. However, there is a lack of research on the long-term effects or changes in student behavior due to the removal of trays in published literature. Roughly 1/3 of the food produced in the United States is lost or wasted along the food supply chain. The FSC refers to the process that describes how the food we eat reaches us through a systematic movement from producers to consumers. The process includes production, processing, distribution, consumption, and disposable phases. Per the Environmental Protection Agency, food waste is uneaten and food preparation waste from residences and commercial establishments and industrial sources. Food waste refers to the food that is fit for consumption but consciously discarded at the retailer or consumption phases. This indicates a considerable inefficient use of resources within the food system. For example, in 2017, an estimated 40.7 million tons of food waste was generated, and only 6.3% was recovered for reuse and recycling, leaving the rest to landfills. Food waste accounts for the largest landfill deposit, followed by plastic, with about 15% of landfills being taken up by food waste. Food in the landfills rot and produce methane gas, which is the second most prevalent greenhouse gas in the United States. Methane has a 21 times greater impact on climate change than carbon dioxide over a 100-year period. The cost of food waste includes the wasting of water, energy, chemicals, and global warming pollution that goes into producing, packaging, and transporting discarded food. Considering these costs, wasting less food in developing habits to save food now could dramatically reduce the need for increased food production in the future. The economic impacts of food waste in the United States are significant. At the retail and consumer level, approximately $162 billion of food per year goes uneaten. Per person, this translates to 1.2 pounds of food per day, with a retail value over $1.40. Social concerns are also associated with the issues of food waste. Over 802 million Americans are food insecure. The social, economic, and environmental implications associated with food waste are substantial, and tackling food waste has become a key topic on political and research agendas. Reducing food waste along the supply chain is imperative, and given their size, universities have a unique opportunity to make changes towards sustainable practices, impacting resource conservation, environmental concerns, and student behaviors. This graphic features how to prioritize actions and strategies for food service industries to reduce food waste and cost, feed communities, and protect the environment. The hierarchy breaks down how food is wasted can be reduced through a spectrum of prevention and secondary uses. Beginning at the top with the best ways of preventing and diverting food waste from a landfill, and it moves down to the least preferred options. University food waste reduction strategies that target dining are ways to reduce volume or source reduction, and such integrated thinking will lead to behaviors and actions that dramatically improve the health of the planet. On-campus dining facilities may be a major source of food and food waste for thousands of students, particularly those who reside on campus. Therefore, it is important to explore opportunities for increasing knowledge on the impact of tray-free dining on food waste to be environmentally and economically responsible. There are 3 types of food waste in a university dining hall setting: pre-consumer food waste, or unavoidable food byproducts, consumer waste, or excess left on plate, and post-consumer food waste, meaning leftovers. In an all-you-can-care-to-eat facility or buffet establishment, including college and university dining facilities, there is a concern that waste is higher in both the front and back of house operations. For colleges and universities, tray-free dining could serve as a solution for promoting sustainability on campus while reducing food waste. In university settings across the United States, about 3.6 million tons of food is wasted annually. Current strategies of resource conservation on campuses include reusable to-go containers, use of waste pulpers, composting, and recycling programs. While finding alternative methods of managing food waste is an option, instead, considering the entire life cycle of products and discovering ways of preventing food waste may be a better approach. As previously stated, many university campuses are moving to trayless dining to reduce waste. Trayless dining is a strategy for decreasing food waste by removing trays from the dining room. Eliminating trays reduces both plate waste and excess student food intake. The University of Texas at Austin created a Fighting Food Waste at UT Austin campaign and implemented many strategies to combat food waste and divert organic waste from the landfill through customer education, operational changes, and waste management strategies. In spring 2008, they assessed waste by audited plate waste during lunch and dinner for 5 days and found students leaving an average of 5.7 ounces of edible food on their plates. After the implementation of all the interventions, in fall 2008, another plate waste audit was conducted and results showed an average of 3.9 ounces of edible food waste. In fall 2009, they moved to trayless dining and the amount of food waste was reduced by 48%. This demonstrates the moderate effectiveness of some food waste campaign methods, but highlights the impacting success of tray removal. A study of food waste completed by Aramark in 2008 removed dining trays to reduce food waste. The study measured food waste from 186,000 meals served at 25 institutions during the 2008 school year. On tray-free dining days, a decrease of more than 11,000 pounds of waste was generated, and food waste was reduced by 25 to 30%, or roughly 1.2 to 1.8 ounces per person per meal. These are positive results. However, this study is difficult to methodically analyze due to a lack of information regarding experimental design, and data analysis was not provided. The food environment is an important factor in food waste, and the removal of trays is a change in choice architecture. For example, a large study observed over 3,000 trays over 2 weeks and focused on the changes in dietary habits as a result of tray removal. The results determined that students self-served fewer servings of lunch entree items and drink relative to students in a dining hall where trays remained in place. Further, the cafeteria with no trays had fewer leftovers. These results suggest that there is less food waste in cafeterias with the adjustment in the food environment and no trays. A smaller study focused on quantifying the impact of trayless dining in a university dining hall. A sample of 360 individuals was recorded with results of a substantial reduction in food waste. Furthermore, food waste production and dish use were highly dependent on the availability of trays. When trays were available, a 32% increase in food waste and a 27% increase in dish use were observed. However, data was only collected over 6 days, with tray availability randomized so that trays were only removed for 1 of 2 meals per day during sampling. To understand the whole process of food service sustainability, Babbage et al. Analyzed 3 stages of dining hall sustainability: food mileage, food waste, and vermicomposting. Food waste was collected over 2 days for all 3 meals. Results determined a total waste of 1.04 ounces per student per day was being wasted. Though this study did not compare tray-free dining to a different service technique to evaluate the true impact of the program. To evaluate the difference in food and compostable waste with and without the use of trays, Sajani et al. Analyzed one university's all-you-care-to-eat facility. The collection took place over 2 separate weeks, Monday through Friday, during breakfast, lunch, and dinner. The first week, with the use of trays, a total of more than 6,000 pounds of food waste, including more than 5,000 pounds of edible waste, was collected. The tray-free week had statistically significant lower waste in all categories, with 5,150 pounds of food waste and 4,103 pounds of edible waste. The significant difference of a p less than 0.01 existed for waste by meals. It was concluded that a flat fee for food in conjunction with an all-you-care-to-eat dining is misleading to consumers and does not take into consideration the environmental and economic burdens that food production demands. In a 2010 study, one researcher compared the impact of using tray versus a trayless system on plate waste and employee attitudes. For 1 week, plate waste was measured with tray system following a week of tray-free dining measurements. A significant decrease in waste per person of 0.81 ounces and a non-significant reduction in liquid waste was observed. Further, employee focus groups determined that they preferred the tray-free system as long as it did reduce waste, but felt that it increased breakage of dishware and increased need to wipe down tables, and those were the concerns resulting from the change. This study demonstrates an initial change in plate waste in that employees are supportive of a change towards sustainable practices. Getty et al. Also compared the tray versus trayless system in a university dining hall concerning environmental impact. Students who used the dining hall were invited to participate in an online survey about their attitudes and experiences with the trayless system. Out of 500 students at every meal, a total of 25 students participated in the survey. Over 70% of those disapproved of the trayless system. This supports the conclusion that tray-free dining reduces food waste, but an additional element to increase student support may be beneficial. From the studies mentioned, it can be seen that tray-free dining can have an impact on food waste in the university dining setting. However, there is a lack of long-term research on the subject, and the impacts on student behaviors are rarely mentioned. This proposal aims to see if the change to tray-free dining maintains a decrease in food waste. Further, as suggested by previous literature, if the change to tray-free dining changes student behaviors towards food waste. The hypothesis for this study is university dining food waste campaign does reduce food waste and changes student behaviors. With study objectives, examine the long-term impacts of tray-free dining in a university dining setting, and determine if this intervention changes student behaviors towards food waste. The study will take place at a university that has maintained a bronze rating in the Sustainability Tracking Assessment and Rating System since 2017. This provides an opportunity for improvement in all areas of sustainability, including dining and food waste. The all-you-care-to-eat food court style facility, food waste will be measured for 1 week with trays at baseline and 1 week without trays starting in the fall semester. A follow-up food waste measurement will take place 6 months later during the spring semester after the intervention has been in place to compare results from baseline and initial intervention measurements. Students will be asked to participate in a self-assessment survey about food waste at baseline and at 6-month follow-up to assess changes in food waste behavior. The students will be notified of the study at the entrance of the dining facility and have the opportunity to decline entrance. The study design is a pre-post design with data collection from one dining facility during baseline, after the intervention period, and 6-month follow-up for food waste collection. The intervention or tray-free dining hall was selected because it is the only all-you-care-to-eat dining facility on campus. To measure the impact of change from tray dining to tray-free dining, solid and liquid food waste will be collected for 1 week or 5 consecutive weekdays, with trays still being used, and for 1 week with the tray-free system, and then again with the tray-free system during the spring semester for 1 week. The dining hall employs a 4-week cycle menu, so the first 2 sampling periods will be 4 weeks apart, and the third collection will take place during the same menu cycle just 6 months later. In order to measure tray-free dining experience in a more natural environment, the switch to tray-free will be made the week after tray dining food waste collection and 3 weeks before the tray-free collection to allow for patrons to become accustomed to the switch. Trays or plates will be placed on the accumulator, and all disposable items such as napkins, straws, and food wrappers will be thrown in the trash. Participants' leftover food waste except for fruit peels and bones will be collected and weighed using a calibrated scale. Participants' leftover liquids will be collected separately from solid waste, and the volume will be measured using a 2-liter liquid measuring cup. After weights and volumes are recorded, all organic plate waste will be discarded through the normal garbage system. All returned plates or trays will be measured to obtain a total amount of food waste. For survey collection, the participant group will be asked to take a survey at 2 points during the study, once at baseline and once at a 6-month follow-up to measure the change in student behavior before and after the intervention. A validated tool questionnaire based on the theory of planned behavior about consumer food waste surveys from Vanderwerf et al. Will be used. The survey uses the expanded theory of planned behavior model to ask questions about food wasting intentions antecedents, including attitudes, subjective norms, and perceived behavioral control, as well as non-theory of planned behavior food wasting determinants. A 7-point Likert scale will be used, with higher scores representing greater agreement with a given question. The areas measured are intentions, personal attitudes, financial attitudes, environmental attitudes, food safety attitudes, perceived behavioral control, subjective norms, and personal norms. The questionnaire is a total of 30 questions, with the first 2 questions being personal characteristics of age and gender. The participant is asked to provide their university email to ensure that there are no duplicate participants and to ensure both surveys are taken and accounted for. For a reward of participation in the study, an entry prize drawing will be offered to incentivize participation. This includes 1 entry to a raffle for a $25 Starbucks gift card that is located on campus and will be offered during each survey collection period. The only cost to the participant is having a meal plan through university dining services, which are necessary for on-campus residents. The setting of this study is the food court-style dining facility and the only all-you-can-eat location on campus. The facility is a fixed-priced Open 7 days a week, offering breakfast, lunch, and dinner Monday through Friday and brunch on Saturday and Sunday. Upon entering the dining facility, patrons pay at the entrance, then procure trays and food from any of the various food stations. Food is served on reusable dishware and eaten with reusable flatware that is returned to a central conveyor dish area when they are finished with their meal. The only changes made in the tray-free dining system will be the lack of trays, and that dinner-sized plates will be used for all meals because they are larger and should be suitable and easier for patrons to carry without trays. Though one option patrons may pursue is to take multiple trips from serving lines to their seats. The participants of the study will be students of the university. And to qualify for the survey portion of the study, participants must be 18 years of age or older. As students enter the dining facility, they will be asked if they would like to participate in the survey portion of the study. The participants must agree to be available for the follow-up survey that will happen in 6 months from baseline survey. Using G-Power software to verify the sample size with an a priori power statistical analysis of the difference between two dependent means was used to provide a total sample size. A minimum of 54 participants is required for a two-tailed test with a power of 0.95, an effect size of 0.5, and an error of probability of 0.05. Due to the length of the study, attrition needs to be accounted for. A minimum of 70 participants are needed and need to be recruited to account for a possible 30% attrition rate. The only inclusion-exclusion criteria are that participants are students at the university and 18 years or older. The potential risks for participating are minimal and only exist in breach of confidentiality. The benefit for participants is decreased individual environmental harm. As previously said, food waste causes substantial harm to the environment, and change in food waste behavior as a result of this study is a benefit to the participant. For food waste, totals will be completed each day. Since the number of dining patrons varies at each meal, waste will be calculated per day and divided by the total number of patrons per day to allow for the results to be compared between sample weeks. An independent samples t-test will be performed to analyze the mean difference using trays compared with not using trays at a 6-month follow-up for both solid and liquid waste. Analysis will be performed by a statistician once data is collected. Data will be reported for all statistical tests. A p-value of less than 0.05 will be considered significant. Evaluation of a chi-square test will be conducted to assess the distribution of data. Correlation analysis will be performed to test associations between the variables of interest. The statistical test will indicate if the removal of trays has a significant impact on the amount of food wasted with a significance level of 0.05 or less. This will determine if there's enough evidence to reject the null hypothesis. The study seeks to prove a strong correlation between the variables. The long-term associations between tray and tray-free dining remains to be undetermined without results. For the survey, categorical variables will be summarized as percentages, and continuous outcomes presented as mean standard deviation or median where appropriate. Mean scores will be developed per behavioral determinant. Cronbach's alpha will be used to measure the internal reliability of the scales used to assess the behavioral determinants of intentions, attitude, subjective norms, perceived behavioral control, and personal norms. If the internal reliability is greater than 0.6, it will be used in subsequent analyses. Linear regression models will be used to assess the relative effects of various predictors on the intention to avoid food waste and perceived behavioral control. The significance of the proposed study is to further describe the association between food waste and trayless dining and whether the difference remains significant after a 6-month follow-up. Further, the study hopes to evaluate the difference in student food waste behaviors after the intervention has been in place. Food waste contributes to a natural resource depletion, while threatening food security and impacting global climate change. A tray system encourages patrons to take more food than they need and either discard the excess as waste or overeat. The tray-free system limits the amount of food taken at a time, theoretically increasing the likelihood that patrons will take only what they will eat. Improving sustainability outcomes with the proposed intervention may lead to universities' further sustainable practices and food waste prevention throughout campus. The theory of planned behavior has been proven to be an effective conceptual framework for examining food waste behaviors. Previous researchers have explained this framework to include determinants related to household food management and have used surveys to measure behavioral antecedents. As Ashton et al. Note, increased time between measuring intention and behavior can impact potential correlations because as time passes, a person's attitudes, social norms, and perceived behavior control can change. And this is why there is a gap between survey distribution at both points during the study. Though, because this study measures participant estimates and/or desired assessment of their behaviors rather than actual individual behaviors, the effect may only be ancillary. However, it could be argued that the survey will have a therapeutic effect on respondents and that this will impact their food-wasting food behavior. There are limitations to the study design. Patrons are not supposed to take food out of the dining facility, but some may do so, especially with whole pieces of fruit. Such food removed from the dining hall is lost to measurement. However, the practice can occur under both tray and tray-free systems and therefore should not affect the outcome of the waste measurement. Other limitations may be from the fact that the dining hall in which the research is to be conducted is part of a larger food service operation. Because of this, researchers may not be able to determine changes specific to kitchen waste, water usage, and electricity consumption. Further, the study does not address whether going tray-free affects the nutritional intake of dining hall patrons. The value of self-reported data has been questioned in several studies on different subject matter, as it seems reasonable for a survey respondent to assess their individual intention to not waste food using an indirect measurement method, being memory, to estimate and self-report their household's food wasting behavior is susceptible to error, including recall and response bias. It does not actually measure behavior. However, the indirect measurement of food waste helps better understand food wasting behavior. Thank you. Do we have any questions? And also, here are my resources.